Hello, welcome to Smart Learning with Sati, and in this tutorial I'll be looking at the concept of functions. So I have a definition on the board here. It says, suppose that A and B are two sets which are related in such a way that for each x, which is an element in set A, there exists a unique y, which is an element in set B. Then we say that B is a function of A. What does this definition imply? Let's see if we can unwrap this step by step. First of all, we know that sets can be defined as a collection of well-defined objects, which can also include numbers. For example, we can say a set of prime numbers which comprises of 2, 3, 5, 7, and so on and so forth. Now, prime numbers in this case can be called the set, and the numbers 2, 3, 5, 7, which are part of the prime numbers, can be referred to as the elements in the set, or better still, the subsets. I believe this is clear. Now back to the definition of functions. Imagine we have two sets and we call these sets A and B, just like we have here. And let's say X is an element in A. That means X can be found in the set A, while Y is an element in B. Now, if there's a relationship between A and B that links X to Y alone, that relationship is said to be a function. Now, what do I mean by this? I mean that if we have set A and set B, of course, we can have other elements in set A. Let's say X, 2, V, W, and then in B, we can also have other elements apart from Y. So Y, 4, J, and C. Okay, these are elements in set B. It doesn't have to make sense, but these are just elements. Now, for us to call the relationship between set A and set B a function, it means that X, which is a set in A, must be paired only to one element in B. So X can only be paired to Y. X cannot be paired to Y and any other element here. X can be paired with 4. But if X is paired with 4, X cannot be paired with any other element. The same thing goes for the other elements. 2 can be paired with J, but 2 can be paired with any other element in B. So that's one criteria that a relationship must fulfill for we to call it a function. Now let's use an example to offer more clarity on the definition of functions. Let D represent the set of dollars and let N represent the set of naira. From the diagram here, we have two sets, dollar and naira, and the elements in dollar are 1, 2, 3, 4, while the elements in naira are 6,000, 4,500 naira, 3,000 naira, and 1,500 naira. We can call all these elements in set D and set N what? Subsets. Now if we assume that the current exchange rate between naira and dollar is $1 to, let's say, 1,500 naira, then we can say that there's a relationship between dollar and naira such that for every $1 there exists 1,500 naira. So once this relationship has been established, we can now go ahead to match the dollar with its corresponding naira. So we have that $1 rather can be paired with 1,500 naira. $2 can be paired with 3,000 naira, right? And $3 can be paired with 4,500, and $4 can be paired with 6,000 naira. Now notice here that no element in D can be paired to more than one element in N. It's like saying, for instance, that $2 is equal to 3,000 naira and 4,500 naira at the same time. It doesn't make sense. Later on in this tutorial, we'll talk more on the criteria that must be met before we say a relationship between two sets is a function. But for now, I hope that this explanation provides clarity to the concept of functions.